All right, let's hammer this last page and get it done. Okay, so thanks for joining if you're having trouble on any of these problems. So welcome to the page that's full of indeterminate forms. If we plug in 4, we get 0 over 0. Remember, you're supposed to try that. If we come over here and we plug in, I mean, you just got to do that. Like on this one, you plug in 0, you get 0 over 0. You're looking for what those indeterminate forms are. So because it's an indeterminate 0 over 0, you know that there's common factors. That just has to happen. So if x equals 4 makes 0 happen, then x minus 4 is a factor of both the numerator and the denominator, just in a sneaky way. So the way that we handle this one is to multiply the top and bottom by the conjugate. And remember, we really stressed the fact last year a lot that the numerator was what I called collateral damage. I really didn't hit it with that conjugate to make it better. I did it to make the bottom better. So if you multiply these out, I don't know, something happened with my headphones, so I'm going to double check and see what happened. I think it froze. Okay, let me see. Let me stop share and see what's going on. I think, yep, okay, I guess we're all right. So let's go back and I don't know why it's changing my headphones, but okay, well, hopefully this works. So we're going to go back here. And if we distribute the bottom, the first becomes x, the outer and the inner disappear. And so now that those kind of cancel, now remember we talked about the fact that they don't really cancel. They just get infinitely close to that value. And so as you plug in 4, you get the square root of 4, which is 2, plus 2, which is 4. So this one, this 0 over 0 story has a limit of 4. Now, if you plug in a half on this one, it's just the nature of the beast. This is what people do. If we plug in a half, you get 1 plus 3, which is, 1 plus 3 minus 4 over 1 minus 1. And so I got 2 minus 4 over 0. Well, people always want to assume everything is 0 over 0, and they do all this crazy work. But the thing is, this is not 0 divided by 0. That means this limit does not and cannot exist. I can't do that because the factor of the denominator doesn't match the factor of the numerator. It would have been a waste of time for me to try to simplify this. So I'm not going to do it. Okay, very similar problem to one of the ones we did before. I'm not going to beat this one up too much, but I wanted the sign of u over u to exist. So I've got a limit of 9. I mean, what are you going to do? It's pretty quick. Now, this next question is kind of different. We have two forms we like. One of them is sine h over h goes to 0 is 1, excuse me. I was about to write the other one down in my head, at least. Or the limit as h goes to 0 of 1 minus the cosine of h over h is 0. Now, that's a little bit of a different, but it's one that is likely to be significant somewhere. So the first thing that I noted about this problem is this is a difference of squares. It's like a perfect square 1, because it's 1 times 1, and that's a perfect square 2, cosine times cosine. So I'm going to do 1 plus the cosine of 3x times 1 minus the cosine of 3x all over 1 plus the cosine of 3x times x. Now, I've rigged this up to where you can, I hope, see that those two pieces would cancel out very nicely. Again, now, under limits, in fact, as you go to 0, this is going to be 2 divided by 2. That's still going to be awesome. But notice that we're very, very close to this one right here. So what we really want to do is we want to make this match and put a 3 here at the bottom and a 3 here. But the funny thing is since this limit is, I still got my 3 on the outside, since this limit is 0, then I guess that makes the limit of 3 times 0 precisely 0. Now, finishing up the last few, I've got the sine of 7x. So remember, we really want to make it look like this first form right here. So I'm going to write the 7x here, and I'm going to write the 9x here, and I want those things to match. Now, unfortunately, in this case, I don't have any x's, but the cool thing is I can put them in. I can put an X in the bottom and an X in the top, and I haven't changed the problem. I can put a 7 in the bottom and a 7 on top. No problem. A 9 on the top and a 9 on the bottom. And this limit right here is 1. This limit is also 1. Because remember, if the sine of 7x over 7x is 1, it would mean that they are identical top and bottom. The only way a ratio can be 1 is if the top and bottom are identical. And that means if you flip it over, they're still identical. So it looks to me like my limit is 7 over 9 times 1. Okay, very similar to the prior question, I'm going to factor out a cosine. So I've got the limit. So if I factor out a cosine of t, I got 1 minus cosine t. Now, this is obviously leading me towards this version over here. So if it's 1 minus cosine t, I'd really like to have a t in the denominator of this, and I have that. So I'm just going to put a 1 under that one. Now, of course, the limit as t goes to 0 of this particular portion we've already established is 0. But as t goes to 0, you get 1 over 1. But 1 over 1 being multiplied by 0 looks definitively to be the number 0 to me. Okay? So we're getting super close to this one. We've just got 2 to go, and we are done with this review. How about that? So limit as theta goes to 0. I got a 1 minus the cosine of theta over the sine of theta. Well, that's kind of a bummer. I don't really know what to do with that thing. So I'm just going to break it up as 2 totally separate stories. And since I would really like to have a theta here, let's go ahead and put a theta there. Now, again, that might seem a little strange that you can do that, but you can. Really, I want to make it fit either one of these 2 forms. I'm forcing that to happen. And we clearly know that this limit right here is 0. We also clearly know that this limit right here is also 0. Excuse me, that limit is 1. But, it didn't really matter anyway, because 0 times 1 is 0. Now, it's funny because I looked at my own work that I did a while ago, and I did some super hard stuff on this thing, or at least somewhat harder than I did now, and I got the same answer, but I kind of like this one better. I used a conjugate. I multiplied by 1 plus cosine top and bottom, and I did a bunch of monkey business, but this just seemed easier to me. And my last one, again, trying very hard to force this to work. A tangent is a sine over a cosine, so that looks pretty good. Now, I've got this 7x, and I really would like this x to be in the bottom, so I think I'm going to go like that, and I have everything that I need, but there's a couple little details that I want. I really would like to have a 4 right here, so I'm going to put a 4 on the top. And the reality is, although I have a cosine, I don't have something that's like a 1 minus the cosine. So I don't think I'm going to be able to get there. So I'm just going to leave this one as a placeholder 1. So we already know that you have 4/7. This limit we already know squeezed in is going to be 1. And as x goes to 0, the cosine is 1. So I got 1. That makes my limit 4/7. But we had to force it to be that perfect situation. And I think we have finished all of the review. That was page 3. All right. Hey, I will see you back in class. Hopefully that was helpful, and I'll see you back in there. Please let me know. Okay. Bye-bye.